Let us study about Ampere's circuital law. So here we will study about the Ampere circuital law. Ampere's circuital law considers an open surface with a boundary. So Ampere's circuital law, it considers an open surface with a boundary. The surface has current I passing through it. And this open surface with a boundary, this has current I passing through it. And the boundary is made up of small elements, each of length dl. Tangential component of magnetic field Bt is multiplied to the element dl, that is Bt cross dl. So the tangential component of magnetic field Bt, this is multiplied with length element dl. All such products are added together, which forms an integral B dot dl. So all such products are added together and this forms an integral B dot dl. Ampere's law states that this integral is equal to mu naught times the total current I passing through the surface. That means B dot dl is equal to mu naught I, where I is the total current through the surface. So this is important about Ampere's circuital law, that integral of B cross dl is equal to mu naught I, where I is the total current. The integral is taken over the closed loop coinciding with the boundary C of the surface. So the integral is taken over the closed loop coinciding with the boundary C of the surface. And here we have Ampere's law, which is the right-hand rule. According to the right-hand rule, if fingers of the right hand are curled in this manner with the thumb pointing in the direction of current, then the direction in which the fingers curl gives us the direction of the magnetic field. When the boundary of the loop is chosen as a circle and the magnetic field is tangential to the circumference of the circle, then B into 2 pi r is equal to mu naught I and B is equal to mu naught I by 2 pi r. So when the boundary of the loop is chosen as a circle and magnetic field is tangential to the circumference, then we have B into 2 pi r is equal to mu naught I, or B is equal to mu naught I divided by 2 pi r. It relates a physical quantity on the periphery to another physical quantity, namely the source in the interior. So Ampere's circuital theorem, it relates a physical quantity on the periphery to another physical quantity, namely the source in the interior. It holds for steady currents which do not fluctuate with time. So Ampere's circuital theorem is valid only for steady currents which do not fluctuate with time. And here also we can see a picture of right-hand rule, which helps us to find the direction of the magnetic field. Next, let us learn about Amperian loop. It is an imaginary closed curve around a current-carrying conductor through which Ampere's law is applied to that conductor. So Amperian loop, this is an imaginary closed curve around a current-carrying conductor through which Ampere's law is applied to that conductor. So Amperian loop is a loop which is first chosen in order to apply the Ampere circuital law, and it circulates counterclockwise. So the Amperian loop will always circulate counterclockwise.